Good afternoon, everyone. Today we will study section 5.3, the fundamental theorem of calculus. There is fundamental theorem of calculus. There is fundamental theorem of algebra. There is fundamental theorem of arithmetic. Do you know the one for algebra or arithmetic? Do you hear me?
Yes, sir, we hear you.
Yes, Professor.
Do you know the fundamental theorem of arithmetic? You know this one, the fundamental theorem of arithmetic. It's about that every natural number you can factorize it into product of primes. Yes, exactly. So you know fundamental theorem of arithmetic. Fundamental theorem of algebra. Fundamental theorem of algebra that you can factorize polynomials in complex numbers, right? Anyway, let's talk now about the fundamental theorem of calculus. Remember to write your names and student ID. So, the fundamental theorem of calculus part 1. If f is continuous in the closed interval, then the function g defined by the integral g of x equals integral a to x f of t dt, x greater than or equal to a, less than or equal to b, is continuous on the closed interval and differentiable on the open interval, and g prime of x equals f of x. See here, you start with function f continuous. You get what? You get continuous and differentiable. So that's nice, right? So you can consider this integral from a to x that it's a machine that give you you give it continuous function on the closed interval. It gives you continuous on the closed interval and differentiable on the open interval. So it's a nice machine, right? See here, and g prime of x equals f of x. So here when I differentiate the integral integral a to x f of t dt, I just put x inside the f. So the result is f of x, okay? Let's solve this one here. So find the derivative of the function g of x equals integral 0 to x square root of 1 plus t squared dt. Okay? How to find the derivative? You need to participate, okay?
Yes, Professor.
Do you know what's the derivative of this? G prime of x equals what? We said that integral from constant a to x, when you differentiate it, you just put x in the function inside, right? So what's the result?
Root of 1 plus x squared.
Yes, thank you. So root 1 plus x squared. So it's easy, right? The function is continuous, so we can apply the first part of the fundamental theorem of calculus. Now let's solve this one. This one is called Fresnel function. What's the derivative of this function? S prime of x equals what?
Sine pi x squared by 2.
So sine pi x squared over 2. Thank you. Now this one is important. You need to pay attention for this example, it's very important, okay? So the theorem tells you that if you have g of x, let's see the theorem again. Integral g of x equals integral a to x. So integral a to x f of t dt, then the derivative is what? G prime of x equals f of x. Good. This is the theorem, but here you have x to 4. Before that, here the input is x, right? Where is the input here? The input here is here, right? X, the upper limit of the integral, right? Good. So this is the idea. So let's continue. So the idea that here the upper limit, okay, when you write it integral a to some to the variable x, this here is the input, okay, because x is changing. Here in our example, we have what? D over dx g of x. But g of x is a function of what? Is a function of x to 4, right? The input is x to 4. Good. So how can we solve this? Using the chain rule, right? So it will be the same solution, but you multiply by the derivative of this, because it's chain rule, right? For example, if you have sine x to 4, how do you differentiate this? It's cosine, right? Cosine, then times derivative of inner for x cubed. Here, same idea. How do you differentiate integral? You put this inside, right? This is the from the fundamental theorem, right? You put this inside, but what's the next step? You multiply by the derivative of inner, right? So let's do that. So derivative of integral, you substitute this in t, so you get secant x to 4. Then you multiply by the derivative of x to 4, you get 4x cubed. Good. Do you have questions?
Yes. No question. No.
Okay. So it's just chain rule, similar to sine x to 4. But if you want to write it, if you want to write detailed solution, you can do like this here. You do substitution. It's chain rule in all cases, but if you want more details, you write m equals x to 4, then you differentiate, you get dm over dx equals 4x cubed. Then here, you change the, I will explain this by writing, it's better because you need to understand this. So let's do this. So you have, again, I will explain in more details. So you let m equals x to 4, then dm over dx equals 4x cubed. Then see here, what's the meaning of this? This means t equals x to 4. This equal t equals 1, okay? I want to change it to m, right? So t equals 1 to what? T equals m, because x to 4 equals m now. So it becomes what? D over dx integral 1 to m secant t dt. So it's just, I call x to 4 m, just call it m for example. Now d over dx, we want to write it different way. So it becomes, I will continue up, okay? So it becomes dm over dx d over dm. Okay, integral 1 to m secant t dt. So this is the understanding of it. What is dm over dx? Dm over dx is here, 4x cubed. So 4x cubed, then secant m. Secant m. But what is m? M is just x to 4. So if you want to write more details, you solve like this. You make m equals x to 4, then you differentiate. Then you put m in the integral instead of x to 4. Then d over dx, you rewrite it like this, dm over dx, d over dm. And then it's clear from the fundamental theorem of calculus that d over dm integral 1 to m, just you substitute m inside. But m equals x to 4, so secant x to 4. This one is also important. The fundamental theorem of calculus part 2. If f is continuous in the closed interval ab, then integral a to b f of x dx equals you call the answer of integral capital F, remember, the antiderivative. Capital F of b minus capital F of a, where capital F is any antiderivative of f. That is a function f such that capital F prime equals small f. We will solve these problems now. I need you to participate, okay? Now, so again, the fundamental theorem, you find the antiderivative, then you substitute the upper minus substitute the lower. Okay, let's now solve these problems. You need to participate, okay? Hamza Yafawi.
أهلا بروفيسور.
Yes, I need your help with the problem 9. Use part 1 of the fundamental theorem of calculus to find the derivative of the function. Do you know how to solve this?
What's the question again?
Use part 1 of the fundamental theorem of calculus to find the derivative of the function.
So you want me to find the derivative of the function for part 1?
Yes.
Question 9.
Yeah. Do you know how to do that?
Not sure, to be honest.
Here you have integral from number to x, right? Here you have 0 in your example. Okay?
Yeah, so.
The fundamental theorem tells you what? When you differentiate this, you just put x inside. So easy, right?
Yeah.
So g prime of x equals what?
G of x
G prime,
prime
of x. Yes.
is going to be f of x. صح.
Square root of x plus x cubed, right?
صح.
Yeah. Thank you, Hamza. Now, Aya Falah.
Yes, Professor.
Help me with problem 10. What is g prime of x for problem 10?
It will be ln 1 plus x is equal to.
Yeah, thank you. Now, Ratib Rabah.
Yes, Professor.
Please help me with problem 11. Find the derivative using the part 1 of the fundamental theorem of calculus. What's the derivative for this?
G prime of W equals sine 1 plus x cubed.
W, right?
Yeah.
Thank you. So sine 1 plus w cubed.
Yeah.
Aisha. Aisha.
Yes, sir.
Please help with the problem 12.
Sir, I'm unsure on how to do it.
So h prime
It will be h prime equal to root u plus 1.
Over u plus 1, right?
Yeah.
Okay. Afshin,
Yes, Professor.
please help with problem 13.
It will be minus root of 1 plus some secant x.
Why minus?
First, you have to do like root 0 plus secant 0 minus root of 1 plus secant x. So it becomes negative.
No, the idea. Yes, you are. But the idea here, the rule tells you from a to x, right? But here you have x to 0. But so how
Yeah.
to do that? Remember, x to 0 equals what? When you flip the limits, you multiply by minus 1. It becomes minus 0 to x, right? Good?
Yeah.
So this is the idea. First you write it this way, minus 0 to x, square root of 1 plus secant t dt. Now you differentiate. You get the answer square root, minus square root of 1 plus secant x. Thank you. Now, Abdullah al-Mutiri,
Yes, Professor.
please help me with this blue question. Is it of the form integral constant to x, 3 to x for example? This one is not, right?
Yes.
Do you know how to do it?
Not sure, but
I will tell you how to do it. Since you have x to x squared plus 1, both have x's, right? So it's not good like this. So we need to change it. But before that, you remember what's the meaning of integration, right? If I ask you integral a to b, for example, you have this function. You are integrating from a to b. What's the meaning of integration? You are finding area, right?
yes.
But if you have point C here between a and b, okay, is the area the same from a to c plus c to b? The same, right?
Yes.
And c you can put it any where you like. You can put c after b if you want, because you know there is it will be correct no matter where you put c. Okay, so let's do our problem now. So this is the idea. We will put constant now to make it similar to the fundamental theorem. So here in our problem you have what? You have integral x to x squared plus 1 t squared dt. Choose any number you want.
2.
Okay. You can write this as what? Integral x to 2 t squared dt plus integral 2 to x squared plus 1. This is the same. No problem. T squared dt. Then the first one is close to what we want, right? But you need to flip them. It becomes minus integral 2 to x. Now it's good. T squared dt. The second one you solve it by the chain rule, right? Integral 2 to x squared plus 1 t squared dt. What's the solution for the first one when I differentiate? So derivative equals what? For the first one, you just put x, right?
Yes.
So minus x squared. For the other part, same idea, but you will use chain rule. You substitute this in t, you get what? You get x squared plus 1 squared times what? Derivative of inner. What's the derivative of inner?
2x.
2x. So this is the solution. Do you have questions about it? Is it good?
Yes, it's good, Professor.
Okay. Thank you. Now, here is detailed solution if you want to call this m. So these are details for the chain rule if you want to write details for the chain rule. Now we have this problem 14. Mayed,
Yes, doctor.
please help me with this problem 14. You have aw equals integral w to minus 1 e to t plus t squared dt. Do you know how to solve it?
I need help.
Yeah. First, the rule tells you what? You have integral, you should have a to the variable x or w. In our problem you have w, so you need to have a to w. When you differentiate this, you get what? For example, if you have fw, I mean ft, just 1 second. So you have ft dt. When you differentiate this, what do you get? You get f of w. So this is the rule. When you differentiate, d over dw. Here you have w to minus 1. It's not constant to w. How to do it? You flip them, but you multiply by minus 1. So minus 1 integral minus 1 to w e to t plus t squared. You can solve it
So
now.
it's a bit similar to flipping a fraction, right?
Fractions.
Yeah. Since you flipped and changed sign.
No, it's not related. Or I don't understand what you mean. But here, when you differentiate this, what do you get? A prime of w equals what? See the rule above. Instead of t, you
So
put
we
what?
replace t with w.
Yes, so minus, then what? E w.
Minus e to the power of w plus w squared.
Yes, thank you.
You're welcome.
Now, Zuhanur,
Yes, Professor.
I need your help with problem 21. So, integral minus 1 to 2 x cubed dx. We need to solve this integral. Do you know how to do it?
You integrate the x cube,
Yes, we get what?
and then you get
X
1
to
over
4.
4.
Yes.
Yeah, x over 4 over 4.
So, x to 4 over 4. From
And
2
then
minus 1 to 2. What's the rule for this? Using fundamental theorem, second part, right?
you calculate
2 to 4 over 4
and then minus
minus 1 to
minus
4 over 4. This equals what? 16 over 4, 4 minus 1 over 4. You get 15 over 4. Thank you. Here is, if you want the graph of the area, here is the graph of the area. See here. Integral a to b f of t dt. You write the function up. It's here somewhere, but it's not in my screenshot. Then you put them a equals minus 1 to b equals 2. Then you get the exact result 3.75. But see here, what's the idea here? That you have negative area. See here down. When it's below the axis, it's negative area. When it's up, it's positive area. Okay? You know about this, right? But if if you want them both to be positive areas, to add them to each other, what can we do? This down is negative area, right? Just multiply it by -1 if you want it to be positive. But what we found is, what's the name of what we found here? Net area, right? If you subtract them, so here down it's negative area, right? When you add them, it's net area, okay? But if you multiply the negative area by -1, it's the whole area, okay? Now let's solve problem 22. Hamza Hassan,
Yes, Professor.
please help with this problem. Integral 0 to 4, just 1 second. Yes, integral 0 to 4 x squared minus 4x dx. Do you know how to solve it?
Yes, you integrate them individually.
So what's the result of the integration?
X to the power 3 over 4.
X to the power 3 over 3, yes.
Oh, sorry, 3. Minus 4x squared over 2.
Yes. Which is 2x squared, right?
Yes.
Then from 0 to 4, then you remember the second part of the fundamental theorem, right?
Yes. Substitute them and then subtract them.
Yes, thank you. So 4 cubed over 3 minus 2 times 4 squared minus, you substitute 0. When you substitute 0, do you get anything? All zeros, right? So 0 here, minus 0. So we just care about the first part. 64 over 3 is 21.3 repeating minus 32, right? Let's hope it's right. No, it's right, no problem with that. Then minus 10.6 repeating. Yes, it's perfect. See here, it's negative area y because it's below the x-axis, see? But if you want it to be positive, just multiply by -1. It's not a big problem. علي سعد علي علي Is Ali here? It seems Ali is not here. Yes, Ali is not here. Ali, Abdullah.
Yes, Professor.
Yes, Abdullah, please help me with this. With this problem. Verify by differentiation that the formula is correct. Here you are given the result of the integral, but how can you know? How can you verify that this result is correct? What do you think?
Professor, I tried to figure it out, but I didn't find
See,
solution.
the question tells you what to do. See, by differentiation. So differentiate the result. If you differentiate the result, what should you get? You get ln x if you differentiate. Do you know how to differentiate the right side?
One over x minus.
So first part we use so d over dx of this. First part we use product rule, right?
Yeah.
So
Yes.
x times 1 over x, then plus
Plus
1 times ln x.
Yes.
Then minus x. What's the derivative of minus x? Minus 1, right?
Yes.
Derivative of constant?
Constant.
0, right?
Yes.
X times 1 over x.
1.
1 minus 1.
0.
So what do you get?
Zero.
Just ln x, right?
Yes.
because you just have Linux. The others are cancelled. So, do you have what is inside the integral? Yes.
Yes.
So this is the solution. Thank you.
You're welcome.
Now, Ali Maher Saad. Sultan,
Yes, Professor.
I need your help with. I will let you choose. Which problem you want? 2 or 3?
It's okay, anyway.
Okay. Same idea. You need to differentiate to know whether the answer is correct. You need to differentiate tan x minus x. You need to get what? Tan squared. Let's do that. What's the derivative of tan x minus x?
Secant squared x
So secant squared x
minus 1
minus 1.
plus 0.
Yes, I forgot the plus here. So plus 0. Then this equals what? Tan squared, right?
Yeah.
This is identity. That secant squared minus 1 equals tan squared. Thank you. Now, Tashir answered me before. Rahil,
Sir.
please help me with this problem. Problem 3.
Okay.
So
What do you want me to do with this one?
you have the result of the integral, okay? The integral of this
Okay.
equals this. The question tells you
Okay.
differentiate the answer to verify that the solution is correct. If you differentiate and you get what is inside here, then your result is correct. Okay? See the first part. We differentiated this.
Okay.
When we differentiated
Yeah.
this, we got tan squared, right?
Yeah.
So same idea.
Okay. So do I first I first do substitution? Yeah.
No need for differentiation. We are doing square root minus the square root of 1 plus x squared over x prime. Do you know how to differentiate this? You differentiate it by the quotient rule, right?
Yeah.
I will
Yeah.
remind
So
you the
yeah,
quotient rule.
after
Yes, tell me.
the like you do quotient rule dy over dx, right?
It will be needed for the square root.
And then I get negative of x squared.
So let me write with you. So minus, then we start with the quotient rule. You have x, then times, you differentiate the square root. You get 2x over 2 square root of 1 plus x squared.
Yeah.
Then minus is out, okay? For the minus in the question. It's here.
Okay.
So forget about it. But from the quotient rule you have minus sign. Then minus x is 1 now, the derivative of x. 1 times the square root.
Okay.
Then down you divide by x squared. Because the formula tells you this one is squared.
Yeah.
Now we need to simplify to get the same answer as here, as in the integral.
Okay, so I simplify it to I can simplify the numerator to minus x squared.
Yes, so minus, keep the minus out, okay?
Okay.
So minus x squared minus
plus
1
1.
plus x squared.
Yeah.
Because we multiplied, we will multiply up and down by what? By the square root, right?
Yeah, can I not do plus square root of 1 plus x squared instead?
Here.
Yeah.
Minus 1 minus x squared.
Yeah.
Yes, you can do that, but we will do it in next
Okay.
step.
Okay. Okay.
Then you divide by x squared square root of 1 plus x squared.
Yes.
Now x squared minus 1 minus x squared.
Yeah.
You will have just minus 1, right?
Yeah.
And times minus 1 out, positive 1, right?
Positive 1.
So 1 over x square root of 1 plus x squared. Is it the same as in the here in the integral?
Yeah, it is.
Yes, thank you.
Okay,
So
thank
the
you.
solution is correct. Now, Yusuf Salah,
Yes, Professor.
please help me with problem 9.
Okay, sure. So okay, so we're gonna integrate x to the power 13 first of all. So it's x to the power 14
1.3.
there's 1.3. Okay. So we use the general rule for integration, which is x to the power n plus 1 over n plus 1.
Yes.
So x to the power 1.3, so 2.3 over 2.3.
Yes. Plus.
And then, okay, so 7x to the power of 3.5 over 3.5.
Yes, thank you. Plus c, right?
Yes, plus c, because this is the indefinite. Yes.
Yeah. Now 7 over 3.5 is 2 if you want to simplify as you like. But the idea here we are just integrating. Now problem حنين السوطاري.
Yes, Professor.
Please help with the problem 16.
Okay. So we'll have 1 over 3x to the power 3
Yes.
plus x plus tan inverse x
Yes, thank you. Plus c.
plus c.
علي ماهر سعد. ماهرة.
Can you hear me, Professor?
Yes, I need your help
Okay.
with the problem. Yes. So how to solve this?
It's gonna be 5x and then x cubed with 2 over 3 divided by 3.
So 2 over
And
3, also another 3 from the x cubed,
yeah,
right?
yes.
Plus,
And then x to the power 4 and then 3 over 4 divided by 4.
yes, thank you. Plus c.
Let's see, yeah.
Afshin answered me before. Then Hamad.
No, yes, Professor.
Please help me with. I will take the problem 14. I want your help with this.
Okay. I'm not sure.
I will give you the first step. The first step you need to multiply because this doesn't have the form of the rules that you know, right? When you multiply, it will be clear. So let's multiply first. You have integral. Remember, t is t power half. Square root of t is t power half. So multiply it inside. You get what? You get t 5 over 2 or 2.5 if you want. 2.5 then plus 3t 1.5. The last one 2t1 0.5 because I'm multiplying the square root inside dt. Now you can solve it, right? You use this rule. When you integrate, you add 1 and divide by the new exponent, okay? Yes, tell me your answer now. Can you solve it now or not yet?
No, no, Professor.
See here, you have 2.5, right?
No.
Just add 1. 2.5 plus 1, 3.5.
Okay.
You divide by 3.5. Then here you have 3 times t 2.5 divided by 2.5 plus 2 over 1.5 t 1.5, because here you divide, okay, plus c. Is it clear?
Yeah.
Did you take the substitution rule? With your professor? Did you study the substitution rule? Do you hear me? Do you hear me?
Sir, I don't think we did, but I'm not sure.
What was the last topic you studied with your professor?
Volume Doctor 6.2 if I'm correct.
Yeah, so it's clear that you also took substitution, because volume after substitution. So let's solve some examples for substitution rule. So substitution rule is similar to chain rule. You have chain rule for differentiation. You have substitution rule for integration, okay? They are the opposite of each other. Let's solve this one now. What's the idea of substitution? The idea of substitution like this. You have integral of what? You have integral f of g of x. See how it's similar to the chain rule. Times g prime of x dx. So what can you do? You can make substitution. For example, m equals g of x. Then m dm equals g prime of x dx. You differentiate both sides. Okay? The m side but dm. The x side but dx. Okay? Then the integral becomes what? Here not m dm, 1 dm, because the derivative of m is just 1. Okay? So dm. So the integral becomes what? Integral of f of m, then g prime of x dx equals what? Equals dm. Good? Do you understand this? Okay, let's solve this problem. What's the good substitution for this? See the rule? This is the rule for integration by substitution. See the example. What should I substitute? What do you think?
I think x 1 plus x squared.
Yes, thank you.
Yeah.
There are more than one option to solve this. You can take m equals 1 plus x squared, or just x squared. Forget about just x squared. You can take 1 plus x squared or square root of 1 plus x squared. Both will work. Me, I prefer to take it with the square root. Okay? I prefer this one. But let's solve both of them so you see which one is better. So dm equals what? 2x dm.
2x.
The integral becomes what? Square root of m dm, right? Good. Then this, what's the answer for this? This is m to half. Add 1 and divide, you get 2 over 3 m to 3 over 2 plus c. Don't forget plus c. Then this equals what? 2 over 3 square root, without the square root. I want just to get m back. 1 plus x squared 3 over 2 plus c, right? Good. Now let's try the other solution. I prefer to take the substitution to be with the square root, okay? So m equals square root of 1 plus x squared. Let's try to do it with the square root. I prefer this solution. Then you square both sides, you get m squared equals 1 plus x squared. Differentiate both sides, you get 2m dm equals 2x dx. Good. Now you substitute n in the integral. So see here, you have 2x dx. You have 2x dx, right? But this equals what? 2m dm. So 2m dm, and what's the square root? The square root is m, right? So times m. Or you can write it what? M squared. Then integrate now 2 over 3 m cubed plus c. And this equals what? 2 over 3 square root of 1 plus x squared cubed plus c. Is it the same solution? What do you think? Is it the same solution?
I think, yeah.
Yes. What do you think? Which substitution is better? Which one would you use when you want to solve such integral?
I think the first one.
The m equals 1 plus x squared?
Yes.
Okay. Now مهر العويدي.
Yes, Professor.
سلامة.
Yes, Professor.
أمين الحلبي. أمين الحلبي.
Yes, Professor.
Yes, okay. علي ماهر سعد. علي ماهر سعد. So Ali is not here. Let's solve another problem. See here, this is the rule. Yes, this one here is perfect. Who wants to help me solving this?
So we can take cos 4x, x cubed 4 plus 2.
Yes, thank you. So m equals x to 4 plus 2. Then dm, what is dm?
dm is 4x cubed plus, yeah, 4x cubed.
4x cubed dx, right?
Mm.
Here you have x cubed dx, right?
Yes.
And here we have x cubed. So it's good. Divide both sides by 4, you get dm over 4 equals x cubed dx. So you get what? You get integral x cubed dx is 1 over 4. Take the constant out. 1 over 4. Then cosine m dm. What's the answer of this? 1 over 4 minus or positive sign. What do you think?
Why is it minus?
Positive, right? Because it's integration.
Mm.
So sine m plus c. 1 over 4 sine what? Sine x to 4 plus 2. Okay, let's stop here. Do you have questions?
No, alright.
Okay. Wish you to get full mark in your final.
Thank you, Professor.
Thank you so much, sir.
My pleasure. Now,
It was a pleasure having you, Professor.
yeah, thank you.
Thank you.
Professor, now we leave.
Yes. This is the
خلاص,
last.
this is the last class.
Yes, this is the last class.
We're gonna miss you, Professor.
Yeah.
نرجع نشوفك إن شاء الله soon.
Inshallah.
Inshallah, see you next semester, Professor.
Yeah.
Thank you, Professor. It was nice having you as our instructor.
Thank you, Professor.
Yeah,
You are the
welcome.
best, wallah.
Thank you.
Wish you all the best.
And you are the best
Bye.
students.
Thank you, thank you. Much appreciated.
Very good students.